I am so glad you joined me for today's discussion of acid-base chemistry. In this segment, we're going to be discussing conjugate base and conjugate acid strength. I call this a level 2 because it's getting a little bit deeper than just identifying or being able to write the formula for a conjugate acid or a conjugate base. Now, one of the things I want to caution us about is language. Language has such subtle differences that can have big differences in meaning. So, when you are talking about conjugate, do not discuss strong and weak. In other words, I hear people say that a strong acid has a weak conjugate base. And we want to be a little bit careful with that terminology. Instead, I want to talk about stronger versus weaker, not strong versus weak. I know it's subtle, but it's important. The stronger the acid, the weaker its conjugate base. Now, let's take a look at this chart that I have here. So in this chart, I'm showing a list of acids with their formulas and their Ka and Kb. So let's come down, let me get some room here, and let's take a look at one of these. If I have formic acid, HCOOH plus water, this is just a refresher on equilibria here. This is weak. It has a Ka, or acid dissociation constant, and we would have HCOO minus plus H3O plus. Its Ka is equal to products, molarity of products, those brackets mean molarity, over reactants, and we don't include pure liquids. So this would be its Ka expression. Okay? Now, its conjugate base formula is HCOO minus. So you notice this is a weak acid. Ka is on the order of 1 times 10 to the minus 4th, which means roughly for every one of these, there's 10,000 product. So it doesn't go very far to make reactant. It's a weak acid. Now, let's look at its Kb expression. So its Kb expression would be for its conjugate base plus water. This is a base. Base is accept, so I'm going to add an H and a plus, and I'll have hydroxide. Notice that it is also a weak base. So this is a weak base. This is a somewhat weak acid with a very weak conjugate base. Now, if you compare these two values, and then we will fill in this chart, how we can compare these values is that Kw, that water dissociation constant, is equal to the Ka, well, let's do it this way because you're used to seeing it like this, OH minus times H3O plus. Well, it is also equal to the Ka times Kb. So if you know an acid dissociation constant, you can always get its conjugate base dissociation constant and vice versa. If we are at 25 degrees Celsius, Kw is 1 times 10 to the minus 14th. So that's how you can go back and forth between a Ka and a Kb. So if you know one, you can always get to the other. So if we take a look at these, you see here that as my acid strength increases, you see that the base or conjugate base strength goes the opposite direction. So the stronger my acid, the weaker my conjugate base. So that's why I want you to use those terms, because you look at one here, that's a weak acid, that's a weak conjugate base. Okay, so that's why we can't say just strong and weak. We want to say stronger and weaker. Okay, so hopefully you'll get that language down. Just to fill the chart out, we have Cl minus, NO3 minus. I'm going to talk about these in just a minute. Actually, I'll mention this. For strong acids, I know it says very weak, but we are going to consider these to be non-reactive. I can fill that in again. Let me show you what I mean. Since HCl or HNO3 goes effectively 100%, that means that the reverse reaction doesn't happen to any perceptible degree. And so if I have chloride in water, it does nothing. It is non-reactive. It has no acid-base properties at all. It will be just a dissolved ion. So one of the things, if you are in advanced chemistry, you're going to want to do is we're going to look at that as a spectator ion, and we'll typically not pay any attention to it. We'll just kind of throw it off as a quick way to get to a net ionic. The same would be true for nitrate. Nitrate would be a non-reactive conjugate. So if I have iodic, that's fairly strong. It's not strong, but it's fairly strong acid with a really weak conjugate. So oxalic acid actually has 2 acidic H's. So this would be just for one of them. I like to write oxalic acid as C2O4. Okay, that's with its H2C2O4. H2C2O4 would be oxalic acid. Okay, phosphorus acid. We always just lose one of the H's when we're discussing an acid and its conjugate. And phosphoric acid, same thing. Okay. Formic acid we saw already. Okay, now that's to show you, the reason they draw it this way is to show you that organic acid group, that carboxylic acid group. This isn't odd, this is not a typo, this is not supposed to be NH3, this is hydrozoic acid, and its conjugate is N3 minus, and then we have OCl minus, and then we've seen, hopefully if you've seen my other videos, you've seen this one, and that would be the conjugate. So you notice that as the base strength increases, its conjugate strength decreases. So that's what you want to focus on when you're looking at these. One of the types of questions that you may run across is this. So you'll see an acid, so this is my acid, this is my base, reaction in the reverse. So for the reverse, this is the acid, would be a conjugate acid, this would be my conjugate base. An acid is an acid is an acid, even if we call it a conjugate acid. So what we're looking at here is which of the 2 acids that we have, which one of these is stronger? Well, the question tells us that the equilibrium constant for this is less than 1. And that means if it's less than 1, remember products are over reactants. If K is less than 1, this is a reactant favored, which means this direction is favored over this direction. So that would mean that HiO3 is the stronger. You can kind of think of it as a push of war. These two are pushing against each other, and the stronger one wins. It forces the reaction to be in the reactant favored side. Okay, so which base is stronger? Well, as you increase your strength of your acid, you decrease the strength of your conjugate base. So if this is the stronger acid, okay, then OCl minus would be the stronger conjugate base, because the weaker acid would have the stronger conjugate base. So that's the type of question you may have to analyze as you consider that stronger versus weaker way of communicating or terminology. Okay, thanks for joining me. I really appreciate it. Have a good day.